Good morning, everybody. So my talk is going to be on interactive visualizations, again with R. And I'm going to be discussing a package that I've been building with Thomas Rinoholson and Kenton Russell. It's called rCharts, and essentially what is rCharts? rCharts is a package that allows you to create interactive visualizations by leveraging the work of several JavaScript visualization libraries. So in some sense, the philosophy that I've used in developing this package is saying, okay, look, the JavaScript community is kind of 100x the size, maybe even more the size of the R community, and they've already built these amazing interactive charting libraries. So why not just take advantage of all the nice work they've done and just provide our users with an interface that they're already familiar with and be able to generate these plots. Okay? So what I'm going to do in this talk is to actually take you through a whole bunch of things, creating with live demos that will kind of help you understand what rCharts can do and essentially how things get built and how you can customize. So here's a simple example of how rCharts uses one of the libraries in the whole mix. So if you can look at the code here, I'm essentially creating a data frame of hair eye color for males. And if you look at the plot command, what goes into the plot command should be fairly familiar to those of you who have used Lattice. So you have a plot of frequency versus hair grouped by eye color, and the data set is hair eye male, and you have which type of chart I want as a multi-part chart. Okay? The only difference is in the function. I'm using a function called nplot. So the convention in rCharts is to sort of use a plot function but append it with a letter depending on the library that's being used. Okay? Fortunately, I haven't run into any alphabetic conflicts so far, so it's all been unique. So if I execute this code here now, so it is actually being executed live, and you see that you get a nice chart. This chart is interactive. So if I hover, I'm able to see some details. I can essentially do some change in behavior, stacking here. I can essentially, select some groups, unselect some groups. And essentially all the interactivity that's happening here is on the client side. So in other words, it's like currently it's a one-way street. R essentially writes the JavaScript, the HTML, the CSS, whatever is needed. And all the interactivity is being driven by the NBD3 package, which is actually a front end to D3. Okay? So you can customize quite a bit. So for example, I'll show you one simple example. So I'm taking the same chart, and rCharts uses reference classes, which was introduced in one of the early versions of R. And what this allows me to do is it allows me to kind of write code where things get saved into the object. So for example, N1 is where my plots are saved. Now I can say, okay, I want the colors to be different, which is obviously the colors don't represent the correct hair colors. And if I do that now, you see that I have the same plot, but the colors change. Okay? Now rCharts leverages multiple libraries, as I said. So the idea is to take these libraries and create a front end that looks more or less consistent for people to use. So for example, this example is another popular library called rCharts. And once again, the interface is fairly familiar. Pulse versus height from this data set, size the points based on age, group based on exercise, and type. So it's a bubble chart. And if you actually look at the interactivity here, this uses all the interactivity here is from the rCharts package. Okay? Just one more example. So this is one of my favorites. It's actually a package, it's a library called Polycharts. And Polycharts is one of the few JavaScript charting libraries that I found which sort of supports faceting out of the box. The visuals are not that great, but overall the philosophy of how they've built it is pretty neat. So you look at it looks like Lattice code, but essentially what it's generating is Polycharts based HTML plot. Okay? And I can again hover on top, I can see things, you can add further interactivity. But all of this, as I said, is client-side interactivity. So you can basically just throw this into a web server and it's going to work. There is no persistent connection required with R at any point. So these are some of the libraries supported. As you can see, there's a pretty huge list out here. We've been adding libraries day in and day out. The advantage of piggybacking on existing JavaScript libraries is that the amount of R code that you need to write is actually very small. I use reference classes, so I'm able to take advantage of certain properties, which I will discuss in a few minutes. Now the same philosophy can be applied to maps. So I've created a sister package called rMaps, which basically takes all the mapping libraries and does the same thing with the mapping libraries. So here is one example. So what I'm doing here is so this is using reference classes. I'm creating a map that belongs to the leaflet class. In the second line, I'm essentially choosing the center of the map. I'm also choosing a zoom level. And in the third line, I'm setting a particular map tile. So if you've used ggmaps, you would recognize many of these tiles. And finally, I want to add a marker, and I want to add a pop-up to that marker. Okay? So now, if I execute this code, you will see that you have a leaflet map showing up. You can essentially pass more parameters based upon the leaflet package. So if I say I want the pop-up to be open by default, it's going to open it by default. Okay? And the way I've done this is sort of using made a generous use of the ... operator, ... argument. So pretty much anything that you pass on, it gets passed on to the JavaScript library in one way or the other, and most of the time, so you basically get almost the full flexibility of the underlying JavaScript library, while the R code is kind of pretty small. Again, another example which I did recently, sort of using Mapbox. So I was curious to kind of look at R user groups across the world. So I got some data from Meetup, added some member information, and essentially the same code, it uses Mapbox instead here. And Mapbox has actually much nicer looking maps. And so here again, you see these are all the R user groups. The points have been colored based upon the number of members in that particular R user group. So basically the same idea I showed you before, except that now it's using mapping packages. Just show you a couple more examples. So this is Choroplex is something very common, and I was always interested in creating interactive Choroplex in a very easy way. So for example, this one over here uses a package called Data Maps. It's again a D3 front end. So you can see that I'm plotting crime versus state, and the data set is a violent crime data set, and you can see that you can hover. I've not added the tooltips, so pretty much information is not really relevant right now. Now I could go one step further, and basically, let's say I want to animate this. So instead of choosing a particular year, I want to animate this. So I want to provide the user with a slider. So I can do this, and essentially what this is going to do is it's going to add an interactive slider, which you can then use to export. Okay. Again, so far all that I've shown you is pure client-side interactivity. So this slider is using another JavaScript library called AngularJS to kind of handle the reactivity. So this can be thrown anywhere on the web, and you don't need a persistent R connection at any point. My final example is again another package called Crosslet. Crosslet essentially allows you to capture leaflet along with histograms that are interactive. So for example, this is a Choroplex map of certain web-based indices across the world for different countries. And the nice thing with Crosslet is that it allows you to kind of cross-filter on top. And bulk of the lifting is being done by Crosslet. So I mean, the amazing part here is actually done by Crosslet. All that I'm doing is sort of provide the R code that would convert it in a format that Crosslet will understand. Okay? So this is how it works. You can add more interactivity. So again, two examples I'll show you. So in this case, again, I'm creating a plot. I'm adding some controls. So I want to control the x-axis. So here again, you see that I get an interactive control here. This is still client-side. Again, it uses AngularJS. I could also throw this into Shiny. So as Winston just discussed a few minutes back, I can create a Shiny UI, and I can create a Shiny server, and I can use a function rCharts2, which is a part of rCharts, that essentially wraps rCharts within Shiny, just like you do render plot. And if you do that, you get more flexibility. And this is an interesting chart because I want to point out sources of interactivity here. So when I hover on top of these points, the tooltip that shows up that is client-side interactivity. On the other hand, when I change this, or when I change the chart type, this is server-side interactivity. So what's happening is I'm changing it to multi-path horizon chart. Essentially, Shiny detects that there's a change in the chart type and basically says, hey, give me a chart with the other chart type, and then it pushes it back to your browser. So this chart would need a persistent R connection, and so that kind of enhances the flexibility of what you can do with rCharts. You can also do custom visualizations. Now I know this is not useful for a statistical audience, but sometimes it actually helps do nice presentations. So I'm a big cricket fan. So cricket is a game played in India, and one of my favorite cricket players is Sachin Tendulkar, and he scored 100 centuries, and I was interested in kind of creating a timeline visualization of all the centuries that he had. So I basically wrote a binding to a library called Timeline, and so this is the data set, and this is the timeline. So essentially what I'm doing is I'm creating a timeline object, I'm feeding it a whole bunch of data, and finally I'm kind of feeding it the match data, and once I render it, you can see that I have this nice looking timeline chart where all the 100 centuries are visualized. And although this might look complicated, these JavaScript library developers have done an amazing job of how things work. So it makes it really easy to just use a little bit of R code and be able to kind of deliver really nice looking visualizations. You could do even more custom stuff. So this is actually a visualization I did with another JavaScript-based, D3-based library called Rickshaw. So this is to visualize the position of a team across the season. So I think this is probably the English Premier League, but not the recent one. So this is all Rickshaw, but created using R. And you can see that these are certain interactive features that Rickshaw kind of provides out of the box. So all we need to worry about is making sure that the data is in the correct format for you to feed it in. Okay. Okay. Now, in any visualization, it's important that you're able to share it with people, and this is usually the problem with HTML-based visualizations because there are a lot of dependencies extra you need. So you either have the option of downloading it as PNG, but then you lose all the interactivity, or you should be able to share and publish. So rCharts comes with a whole bunch of functions to kind of make your life easy. So you could use the save method to save the chart to your file folder, and then you could share it with people. Or you could, sometimes you just want to publish it without really doing anything more. So I need to exit this for a moment. So let me use my instance of R. So let me just create a plot, and so I'm creating a plot. So let me just say R plot. MPG versus weight, data, empty parse, type equals point, and let me set the color to be based on the variable here. Okay. So now I could just say R1 $publish, and I can say my chart from user 2014. And so what it's going to do is it's going to actually save the chart for you and push it to the web. It uses gist to essentially do that. And once it gets pushed, you can actually, you will see that the chart is there here. This is a website, again, I built using some other open source tools that sort of provides a viewer for people to play around with. And once charts get published, they can also be, people can also edit it online to kind of play around with it. So for many of the charts, I'll post the links to this. You will see a edit button, which allows people to sort of interactively play with the code, and so this kind of allows people to sort of see what the package can do without really downloading the package and doing things. So that's as far as sharing is concerned. Now, how it works. So I'm just going to spend a few minutes explaining how it works. So the key idea is, so unfortunately this embed doesn't work. So this is a chart I'm trying to reproduce. Okay, so I'm going to write a new binding for this particular chart. So if you look at any chart, you can basically strip it into a bunch of pieces. So the first piece is essentially your dependencies. So what I do is all the dependencies, rCharts has a config.yml file, which essentially captures all the dependencies, so that when you try to draw the chart, you don't have to worry about including all of them. rCharts already knows what are the things it needs to include. Then you have the chart itself, the JavaScript generating the chart itself. And if you notice JavaScript, the key question I always ask is, what part of this is boilerplate, what part of this is data, and what part of it is options, right? We only want R to deal with the data and the options. We don't want R to deal with the boilerplate. So I split this into two parts. This is your boilerplate, and the funny looking mustaches here are essentially placeholders. This is where data will be supplied from R. So chart params is actually a JSON variable that R will kind of build and pass on to the chart. So the final step actually is how do you get data into the format that's required by these libraries, right? I mean, people with writing R packages usually are generous. They kind of always try to use X, Y data as their, and people know that data frames is what they use. But JavaScript visualization libraries have like a whole bunch of different formats, and so bulk of the code you end up writing actually is doing these transformations. So this is the data. I need to convert it to this JSON. So I just write, in the package, I write a function that would handle this conversion. And finally, just wrap it into a function. So this is an example of a function that I call uplot, because the library is UV-charts. So you see what's happening. I'm kind of setting it as a child object of the rCharts class. And then I'm setting the library to this particular folder. And then I'm just passing on the parameters that the R user passes. Okay? So once you do that, you can basically, so this is, I'm just showing you the same, what I did before, I'm showing you the result of that. You can basically run this code, and you see that you get head versus frequency with the group being sex. You can also play around with this. If you want to swap this, group this head, and X is sex, you get a slightly different looking chart, and unfortunately I think, actually it shows the full one. So this also has some interactivity that's kind of there. So to conclude, rCharts, again, the philosophy here is a little different from GGVS. GGVS is using Vega, has a robust grammar. rCharts doesn't have a robust grammar because I'm just piggybacking on top of all these wonderful visualization libraries out there. But the advantage, one advantage of that is a lot of custom visualizations can be created and made reusable from rCharts. And so as an example, let me show you some charts that other people have been contributing. People have been writing bindings. There is a whole gallery of rCharts creations. So essentially, you could do paddle set charts, you could do Sankey plots, and let me just get the Sankey plot example here. Okay, let me just do paddle sets, yeah. So this is a paddle set example. So people have been writing bindings that would sort of allow you to explore like all these D3 examples. So my hope, or my hope in the long run is that people will contribute a lot of like nice looking charts and make it reusable so that the R community can benefit from it. And pretty much like you browse through a whole library and you say, hey, this chart is what I want, it looks interesting, how do I use it? Okay, this is the R code that I need to write to use it, and I'm going to do that. So that's essentially what I have to share. If you have questions, I'll be happy to. Thank you. Okay, so I did a workshop on interactive documents yesterday. So I have a package called Slidify that generates slides, and I integrated with Shiny to sort of write a function that would create an interactive presentation package. So actually, it's actually running. It's running as a Shiny application in the backend, and I can't allow people to execute arbitrary code. So when I post it, I will switch to OpenCPU, which is another code execution framework, which actually is secure. So when I post it, you'll be able to run this code in the browser itself.
If I want to share this type of data within an organization because the data is very sensitive, and is there a way I can keep this graphic?
So usually with D3 based graphics, the data is in the DOM. So essentially, if you put the file on a public server, right, you can't hide the data. You will need to kind of use Shiny or any server framework to kind of send the data. Can I integrate with Tableau? I'm not sure. Tableau has an API to sort of create those things. So, but I'm not kind of written anything that would go from R to Tableau. So I'm not very sure how exactly it can be done.
Just one more
how to make animations. So this is one serious limitation with rCharts. Essentially, I can only do stuff that the JavaScript library author has sort of built into the package, right? So if that particular package provides animation, then I can do animation. Otherwise, it's going to be hard to do animation. So so that's one serious limitation. You can only do what is sort of already built by these people. One more question or no? Done? Okay, thanks. And if you have questions, ask me. Thank you.